In this video, we will solve a problem that was asked in ISI MSQ 2022 regarding how to find the price elasticity from the given monopoly problem. The question is like this. Suppose total cost for monopolist is being given as is C is equal to 3Q square plus 800, where Q denotes the output, and demand function is being given as P is equal to 280 minus 4Q. P is the price, Q is the output. What is the price elasticity of demand at profit maximizing price? The options are minus 4.5, minus 3.5, or minus 2.5, or minus 1.5. Okay, so for first thing is first, that means first we need to find out the profit maximizing level of price. Okay, after that we can calculate the elasticity of demand, that is price elasticity of demand. Now what we are being given, we are being given the demand function, that P is equal to 280 minus 4Q. Okay, this is the inverse demand function. Since we have to first calculate the profit maximizing price, that means we need to find out the profit maximizing condition. Profit maximizing condition in case of monopoly is marginal revenue should be equal to the marginal cost. Now to find the marginal revenue, we need to find out the total revenue, and similarly to find the marginal cost, we need to to find the marginal revenue, we first need to find out the total revenue. Similarly, to find the marginal cost, okay, we need to find out what is the total cost. Okay, that is also given here. Now this is our demand function. Now total revenue, as you know, is simply equal to price into output. So price into quantity gives us the total revenue. So multiplying this 280 minus 4Q with Q, this will give us the total revenue as 280Q minus 4Q square. This is our total revenue. Okay, this is our total revenue. Now marginal revenue is simply the derivative of total revenue with respect to output. Okay, so this is our total revenue. Taking derivative of this function with respect to quantity gives us marginal revenue. So the derivative of Q is 1. So we are left with 280 minus 4 2s are 8 Q. I have explained all the stuff how do we do the differentiation. Okay, so I'll not go into the details. I have the limited time this time. Okay, so I have to do another stuff. So this is our marginal revenue. What is our total cost? Total cost is being given as a C, that is C is equal to, let me write it here, 3Q square plus 800. Now marginal cost is simply the derivative of total cost with respect to output. So 3 2s are 6. By power function rule, I get the total marginal cost is 6Q. Okay, simple stuff, no bakwas. Now what is our profit maximization condition? Our marginal revenue should be equal to marginal cost. Marginal revenue is this, marginal cost is that. So this is 280 minus 8Q gets us barabar 6Qs. That means 280 is equal to, transposing this here, so this will become shata or get 14Q. Okay, which means Q is equal to hey go mushti. So 280 upon 14. Okay, transposing this, and 14 ones are 42s are, that means 20 will be our profit maximizing quantity. Okay, now we got the profit maximizing quantity. What will be the profit maximizing price? Just plug this value Q is equal to 20 in our inverse demand function. So we have here 280 minus the value of the profit maximizing quantity. So in place of Q we have 20. This comes out to be 280 minus 4 2s are 80. This comes out to be P will be equal to Zasheet minus sheet is 200, I guess. Okay, so this is our profit maximizing level of price. Now we can calculate the elasticity of demand. Okay, so elasticity of demand is simply equal to, so elasticity of demand, that's price elasticity of demand, is equal to dq upon dp into p upon q. Okay, so we need to find out dq upon dp, this very derivative. That means we need to find out the change in quantity with respect to price. We are being given the inverse demand function. First we will solve this for Q to solve to get this derivative. Okay, so since this is our inverse demand function, P is equal to 280 minus 4Q. Let us solve it for Q. So transposing here, 4Q will be equal to 280 minus P, and Q will be equal to 280 upon 4 minus 1 upon 4P. You know how do I do calculated this. Okay, so Q is equal to 4 7s are, so we got here minus 1 upon 4P. This is our demand function. Okay, this was inverse demand function, which was in terms of, you know, explicitly in terms of p here, and this is our usual demand function. Now to find dq upon dp, we can now calculate dq upon dp. dq upon dp is just the derivative of this function with respect to price. Derivative of constant is 0, the derivative of p is 1. We are left with minus 1 upon 4. Okay, so now we have the final touch here. So let me rub something here. So to find the price elasticity of demand, we have price elasticity of demand is equal to dq upon dp. We calculated is minus 1 upon 4 into p into q. So profit maximizing level of price upon profit maximizing level of output. So this is our profit maximizing level of price, this is output. Okay, so p upon q is 200 upon 20. You go yes with 2 ones are 2 tens are, so we are left with minus 10 upon 4. This comes out to be minus 2.5. So our price elasticity of demand will be minus 2.5. And how do we interpret this minus 2.5? Simply it says if price increases by 1%, quantity demanded will decrease by 2.5%, and vice versa. I hope I make myself clear in this video. Thank you.